Okay, we have a 20 megahertz probe, one of the new probes that will come with the scope, and we've connected it up to the probe adjustment test point, and we're going to go ahead and calibrate this probe and show you how that's done. Connect it so it's easy to get to the screw here. There is a screw hole right here on the probe. You insert a small screwdriver while you're connected to the test point, and you adjust yourself to get the flattest curve that you can. Now that's overcompensation, undercompensation. There you go, straight on. That's what you want. As square a wave as you can get. Okay, so that probe is calibrated. And then we're going to use this probe now to measure DC voltages that we're going to take from our analogic voltage standard here. We're going to dial in the voltages that we wish. We're going to read it on DC. Go ahead and connect myself up. Okay, we're going to turn off the lights here a little bit, and it'll allow us to see the scope better. Let's go ahead, and we're zeroed right now. We are on the 0.01 volt per division. And we are dividing by 10 through our probe. So in order to get 0.01 at the scope, that means we have to put 0.1 in at the probe tip, and that's what we're going to do. So we'll have steps of 0.1. We should see ourselves go up each division. So here's step 1, 2, 3, 4. Let me turn the illumination up for you. 5, 6, 7, 8. Perfect. All right. Let's go to the 0.02 volts per division. This is going to take 2 steps for each division. So here's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to need to go up. If I go a volt, see if I back off 2 and go a volt, that should put us at maximum. And there we are. So that's 1.6 volts. 0.02 volts per division times 8 would be 0.16, so if I've got 1.6 volts divided by 10, that's 1.6, so we've done it. Let's go ahead and to the next position. Take this back down to 0. 0.05 volts per division. And we will go... I'm going to put a volt at a time in, divided by 10 to be 1/10 of a volt, and that would put me 2 divisions at a time. So I'm going to go 2 divisions up. 1, 2, 3, 4. Perfect. Okay. 0.1 volts per division. And I'll go ahead and put the 1 volt signal in. We're divided by 10. That'll give us 0.1 per division. So I'll go 1 volt at a step at a time, and we'll see. Here's 1 division, 2, 3, 4, 5, 6, 7, 8. Okay. All right, if we go 0.2 volts per division, I'm going to go ahead and remove the times 10. We'll go direct. I'm on 0.2 volts per division. I'm no longer dividing by 10 at the probe. I'm going to put in 0.1 volt at a time, so I'll go half a division. 1, 2, 3, 4, 5, 6, 8, 9, 10. So that's 0.1 volts. We've put in 10 of those, so we are at 1 volt, and we are on 0.2 volts per division. Times 5 is 1 volt, so that works great. Let's go ahead and back off. There we go. That should raise us up full scale. We're at 1.6 volts coming in. We're on 0.2 volts per division. Times 8 would be 1.6 volts. So that worked. Let's go to 0.5 volts per division, and we'll take ourselves back down to 0. Okay. We're going to go be 2 steps at a time because I'm going to put 1 volt on at a time. 1, 2, 3, 4. Perfect. Okay, we're going to go 1 volt per division. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 2 volts per division. We'll have to go 2 steps at a time. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Technically that's about all I can get out of this to display, so we'll stop with that one. If I go to 5 volts per division, I've got 10 volts coming in. I'm going to have 2 volts on the display, and that's what I have. There's 5 volts at that point. I'm 1 division. And 0. And at this point, I'm going to switch calibration devices to a Heathkit calibrator that I have that's capable of putting out 100 volts. We'll take a look at it in a moment. Okay, we've loaded in voltage from this Heathkit calibrator here. It's roughly 100 volts loaded down. It's going to give us something less, so I have a voltmeter, digital voltmeter reading the voltage on it. At the moment we're reading 99.42. I'm going to go ahead and put it on the scope. Oops, there we go. And what we see is that we've risen 1, 2, 3, 4.8 divisions of rise. And we are reading 98.08. We have a roughly 100 volt signal coming in. We are on the 20 volt per division setting of the range. So that would 100 volts would be 5 divisions. 98 volts would be 0.2 divisions lower, so the 4.8 would correspond well with the 98 division, 98.08 volts. So that's the best we can do on this range with the equipment that I have available. Let's go ahead and switch to channel B. Okay, as you can see, we are now connected up to channel B. And we are, since we are already hooked up to the Heathkit, we're going to start at the opposite end of the range switch. We're going to start at 20 volts per centimeter, or per division. And we'll go ahead and put ourselves online. Right now we've checked our ground point, and we see we've risen now 4.8 divisions, and we are getting a reading of 98.11 volts. The 98 volts would be 4.8 divisions, so this is reading accurately on the 20 volt per division line. Let's go ahead and switch back to the analogic voltage calibrator, which would be this unit, and we'll do that in a moment. Okay, we're connected up to the analogic, and we're going to go ahead and start applying voltage. We're on the 5 volt per centimeter or per division scale. So every division up there is 5 volts. I'm going to be putting in 1, 2, 3, 4, 5. First division. 1, 2, 3, 4, 5. There's the second division. There's 10 volts. Let's go ahead and back that off. Go to 2 volts per division. Alright, now we should be half a division at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. One volt per division. There's 1, 2, 3, 4, 5, 6, 7, 8. Half volt per division. I'm going to go 2 at a time, 2 steps. 1, 2, 3, 4. Okay. 0.2 volts per division. And there's 1 volt that puts us up 5 steps, and then we'll go 1/10 of a volt at a time. There's 1.1, 1.2, 3, 4, 5, 1.6. And take away the volt. Okay. 0.1 volts per division. Here we go. Step at a time. 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. And 0.05 volts per division. Just making sure I've got a good baseline there. 0.05 per division. I'm going to go ahead and divide by 10, and we will go 2 steps at a time. There's 1 volt divided by 10 is 1/10 of a volt, and we are on 0.05, so 1/10 of a volt would be two divisions. Go to 4 divisions. Make sure we're zeroed. Looks like we're below the line, sorry. 2, 4, 6, 8. Okay. And then we will go to 0.02 volts per division, and we will go 0.02, so if I put in 1/10 of a volt, it'd be 0.01, it'd be a half a step at a time. So let's, there's a half, there's 2, 3/10, 4/10, 5, 6/10, 7, 8/10. Let's go 6, and then we'll add a volt. Okay. All right, we're on the 0.05 volts per division centimeter range, and we're going to step 0.1 volts per step here, so we're going to wind up going 2 divisions at a time. So there's 1, 2, 3, 4. That was perfect. All right, let's go 0.02. And we will go 0.02. There's 1, 2, 3, 4, 5, 6. And let's go volt. That should take us to the maximum. That's 1.6. Okay. And then finally, the last step, 0.01 volts per division. And here's 1 step, 2, 3, 4, 5, 6, 7.08 volts. Perfect. Okay. So that does it for channel B ranges as well as channel A. We're getting good vertical response to our voltages, and we had great time-based response. So now we're going to put it together with some triangle waves and see how we do.